So in this recording, we will see why model graded evaluation, which we commonly use using the various evaluation frameworks like TrueLens, Ragas, Phoenix, DPVal, right? Those are various model graded evaluation framework. We'll see in this recording why only model graded evaluation may not be enough. We cannot just depend on model graded evaluation, where they can go wrong, right? To understand this, we will look at the Raga's answer correctness evaluation metrics, which is again a model graded evaluation for scoring the correctness of the answer, to score how grounded the answer um, is to the ground truth, or how correct is the answer based on a given ground truth. Now, this answer correctness is a groundness type of metrics. It is not a reference-free metrics. The difference between reference-free and groundedness metrics is, in groundedness metrics, you need the ground truth. In reference-free, you don't need the ground truth, right? So answer correctness is a groundedness ground truth metrics where you need the ground truth. It's not a reference-free metrics. How it is calculated is, there are two metrics that are calculated. One is the factual similarity score of the answer, which is this entire process here. We'll go through this entire process and it's in the code how it is done. And then the semantic similarity of the answer to the ground truth. So basically it's a, if this is my answer, this is my ground truth. Semantic similarity is nothing but the embedding distance between the two, right? Is a semantic score of this two, right? The answer correctness, the final score, is a combination of these two scores, and you can provide individual weights to each of the score. For example, you can say 0.75 for factual similarity, 0.25 for semantic similarity, or the other way around, right? And we'll see this and see where it goes wrong. So the factual similarity is the model graded evaluations. There are two models that are used. One to do the long form answer format, and I'll explain what this is. And the other is the correctness prompt, right? And we'll see that while doing the model graded evaluation, the model is hallucinating here. And that is the reason why we cannot completely depend on model graded evaluation, right? So the factual similarity, how it is calculated. Let's go through this process first through this PPT, through this slide, and then we'll look into the code also. So to calculate the factual similarity, there are two things that happen, right? In the first one, a model is used which is given the question, the answer, and the ground truth. Based on the question, answer, and ground truth, the model creates two lists. One, the rephrasing the answer, the other rephrasing the ground truth. When I say rephrasing the answer, it is actually what it does is, if there is an answer, it tries to simplify the answer or break down the answer. So if the answer has two statements, it breaks down the answer into two statements. And let's say in the ground truth also, if there are multiple statements in the ground truth, it breaks down the ground truth also into multiple statements. So after this phase, I have my answer broken down into statements. The simplest way of breaking down into statements is to line by line, right? Each line is a statement, right? If my answer has 5 sentences, I'll have 5 list of 5 sentences here. If my ground truth has 10 sentences, then I'll have 10 sentences, list of 10 sentences here, right? After this is done, a model is used which takes each answer and sees if that answer, like the broken down statement, right? It's statement, and sees if this statement is present in the ground truth. If it is present, then it is true positive. If it is not present, then it is false positive. If it is present, but if it says like positively, but here it is negatively, it will be false negative, right? So that is what is done by this step here. This is again a model graded evaluation where each answer is compared with the ground truth statement to see if it's a true positive, false positive, or false negative, right? Finally, the output of this step is a uh, like for each statement, whether it's a true positive, false positive, or false negative, right? Once I have this true positive, false positive FN, right, I can now calculate the F1 score, right? Um, so F1 score, and then once I have F1 score, is that this F1 score is my factual similarity, right? And then based on the weightage, I can do the final score. So if you go to the documentation of ragas, you will see this is the calculation that they have explained here. And F1 score is calculated by the sum of the true positive by the true positive plus 0.5 into false positive plus false negative, right? This is the comparison, or this is the calculation. Let's look at the code now, right? And we'll go through the code one by one, right? So this is the um, this is the this is how you create a Python program to calculate the answer correctness score. I took it from this example here. So if you see, this is the example, and I made some changes, right? What changes I did is, instead of two questions, two answers, two groundedness, I just started with one answer, one question, answer to this question, the ground truth for that question, for understanding it easily what is happening here, right? And then so here default is used as GPT 3.5. I was trying with multiple models, so I instantiated GPT-4. And then the other thing that I did is, so here the default weight of semantic similarity, I think if it is not there, I think it is completely using factual similarity. But here I gave the weights as 0.1 for factual similarity and 0.9 for semantic similarity, right? And this is the Raga's logic to calculate the answer correctness. Let's see how it is calculating it. Let me go directly to the A score one, right? So if you see here, A score, the first thing it does for item in answer and ground truth, right? So we have answer and ground truth, right? For each answer and each ground truth, it is creating this, it is breaking down into simpler statement, right? So for example, what we saw here, right? Rephrasing this and rephrasing this, right? Not rephrasing it, decomposing it into the answer, right? This is what is happening here. So if you go to create statement prompt and go to the prompt that it is using, this is the prompt. So if you'll see, the prompt here is, given a question and answer and sentences from the answer, analyze the complexity of each sentence given under sentences and break down each sentence into one or more fully understandable sentence, which also, while also ensuring no pronouns are used in each statement, right? Format the outputs in JSON. Some few short examples are given. So for example, if the question is, who was Albert Einstein and what is he best known for? And if this was the answer, he was a German-born theoretical physicist, widely acknowledged to be one of the greatest and most influential, right? If this is the answer, and if these are the sentences, ground truth sentences to create the answer, then how it is broken down into simpler statement is, right? So the first one is, he was a German-born theoretical physicist, right? So Einstein was a German theoretical physicist, and then Albert Einstein is recognized as one of the greatest and influential of all time, right? So this sentence is broken down into two sentences, right? This is what is happening here, right? The answer is broken down if it has multiple statements, right? It gets broken down into this one, right? And then the sentence index 1 is where your the sentence, right? So this is your ground truth, right? So the ground truth is also broken down into simpler statement, right? That this is how it is this is done, right? So first it is done for the answer, then it is done for the ground truth. When answer is there, both your answer, so your answer will have whatever is the answer, and the sentences will have the ground truth. In case of ground truth, both answer and the sentences will be your ground truth content, right? So at the end of this, I'll have a broken down answer and broken down ground truth, right? And then as I said, for each answer, now it is checking if that answer is contained in any of the sentences, right? Based on which the TP, FP, and FN are calculated. Let me go back to the answer correctness thing, right? So this is what is happening here in the A score. Let me go back to the A score, right? So for item in answer, ground truth, self-create statement. So at the end of this for loop, right, I have what I have. I have when the for loop end. Okay, this is where the for loop ends, right? I have a item statement list and a statement list, right? So one is the answer phrases, one is the ground truth phrases, right? So actually this is where it is happening, right? After so it is still after this, right? I have a list of those broken down ground truth. I have a list of those broken down answers, right? Which is these two are then provided to the correctness prompt format, right? So correctness form prompt the template works here. If I look at the correctness prompt template, here you will see again, this is how it is happening, right? So if this was the question, the answer after it is broken down into two, the ground truth is also broken down, right? Then for each of those broken down answer, right? For example, here, how it is saying, how it is classifying. This is an example, right? If okay, so it takes this one, the primary function of the sun. If this is the primary function of the sun, it is saying that it's true positive, because the primary function of the sun is to provide light to the solar system, is matching with one of the statements in the ground truth, right? And through this few short example, it is saying how to calculate true positive, and also provide the reason of why it marked as true positive, right? So it does for each and every sentence. So this was the first, this was second sentence actually. Then it, I think, took the second sentence. The sun is powered by nuclear fission, right? Here it is a false positive, because this statement is incorrect and contradicts the ground truth, which states that the sun is powered by nuclear fusion, right? So in the ground truth, sun is powered by nuclear fusion, right? So this contradicts, so it's a false positive, right? That is what is happening in this step here, right? So at the end of this, let me go back here. You were here. Let me go back to the score. So after I broke it down, after I have the ground truth answer, correctness prompt, this is where I am calculating the TP, FP, FN, and finally I compute the F1 score with those TP-FP here, right? Once the F1 score is calculated, I calculate the semantic similarity here, right? And then after the semantic similarity is there, I take an average of the F1 score, which is your factual accuracy, and your similarity score, which is your semantic score, the average is done based on the weights, right? That's what is how it is happening, right? But where it is going wrong, right? Let me show you this, right? So I took the factual accuracy prompt separately, right? The prompt that I have earlier shown you, right? With few short examples, like how it should uh, break down the answer in small, right? Those are there here, right? Now, the question I'm giving is, when was the first Super Bowl? The game of baseball was held on January 15, 1967, right? When you run this, when you come, it will try to rephrase this to make it simpler, or if it was having more than one statement, it will break down into two statements, right? So for example, let's say, okay, first I'll run this and see what happens, right? And this is where the hallucination happens, right? So when I said, when was the first Super Bowl, right? The first, see, it rephrased this answer. The first Super Bowl took place on January, right? So it completely changed from the game of baseball to first Super Bowl, right? So definitely this evaluation, the factual accuracy will not be correctly scored, because here the LLM actually rephrased the question, rephrased the answer based on the question, right? So that is the problem. But how this step works, so for example, if I say, and it is held in France, you'll see that it will break it down into two statements, right? It will say the first Super Bowl, right? The first Super Bowl was held in France, but it it completely hallucinated, right? When it, right, because the actual answer given by the generation LLM was that it was talking about game of baseball, when, and the evaluator, right, should be able to catch that. But now the evaluator will not be able to catch that, because in this phase, when rephrasing the answer, the LLM is recreating this answer, completely ignoring the game of baseball and trying to align it with the question, right? So that is a big issue, right? That is one of the things that is currently a challenge with model graded evaluation, right? So you don't know where it may go wrong. That's why it is important that not to just depend on model graded evaluation, also add some additional scoring technologies, right, which probably is more deterministic, and then create a composite score. For example, in ragas, you have semantic similarity and factual similarity. Together, it's giving a final score. I can actually add one more, right, where I can check the average, what do you call it, like average token size, or average uh, length of the answer, or even I can put in, if there are certain keywords I want in the answer, right? I can create my custom score to see if some certain keywords are there or not, right? So a composite score by like weighted composite score with different metrics, not just model graded eval metrics, is recommended to make the LLM evaluations more robust, more efficient. Over a period of time, I think the models will go stronger. So over a period of time, the model graded evaluation may become better, but we should always be reduce our risk by adding additional metrics and calculating a composite score. That's what I wanted to explain in this demo. Just before closing it, I would like to run this with 0.1 and 0.9, and I want to show you how it is running. Right. So at the end, you will see that, so here 0.1 is my factual accuracy, right? And 0.9 is my semantic accuracy, right? So with that, it came 0.9, right? So if I make the factual accuracy 0 and semantic 1, you will see that the score will further further go down because of the game of baseball, right? The difference between the game of baseball and the Super Bowl thing, right? So it went down now. So this is what I wanted to show as part of this recording. Thank you.